In 20 through 38, determine whether the statement is true or false. Justify your answer with a proof or a counterexample as appropriate. In each case, use only the definitions of the terms and the assumptions listed on page 161, not any previously established properties. Every positive integer can be expressed as a sum of 3 or fewer perfect squares. Now, this statement might seem true, however, there is a counterexample, and that is specifically 28. There are more counterexamples out there. However, 28, I would say, is the easiest counterexample since it's the smallest positive integer that cannot be expressed as a sum of 3 or fewer perfect squares. Well, since 28 is not a perfect square, then we need at least 2 perfect squares. So let's start by looking at all the combinations of 2 perfect squares. If we start with 1 squared, then we would have 27 left over, and 27 is not a perfect square, so this fails. If we try 2 squared, then what would be left over is 24, which is also not a perfect square, so that doesn't work. If we try 3 squared, that's 9, which would mean we'd have 19 left over, but 19 is not a perfect square. If we try 4 squared, that's 16, which means there's 12 left over, and 12 is not a perfect square, so there's no solution. If we try 5 squared, then we'd be left with 3, and 3 is not a perfect square. 6 squared is too big. So that's the proof as to why we can't write 28 as the sum of 2 or 1 perfect squares. But what about 3 perfect squares? Well, this one's going to be a little bit trickier. We could start by guessing if one of those perfect squares is 1 squared. That would leave us with 27 left over. Well, if I try 1 squared, then that would mean I would need 26 to be a perfect square, but 26 is not a perfect square, so that doesn't work. We could try 1 squared plus 2 squared. That's 5, which would leave a remainder of 23, but that is not a perfect square. We could try 1 squared plus 3 squared, but that's 10, which means we'd have 18 left over, and that's not a perfect square. We could try 1 squared plus 4 squared, but that leaves us with a remainder of 15. But 1 squared plus 4 squared is 17, which leaves a remainder of 11, and 11 is not a perfect square. We could try 1 squared plus 5 squared, but 1 squared plus 5 squared is 26, which leaves us a remainder of 2, and 2 is also not a perfect square. And if we try 1 squared plus 6 squared, this is too big. All right, let's review what we've done so far. We've shown that 28 is not a perfect square, since the square root of 28 is not a clean integer. We've shown that 28 is not the sum of 2 perfect squares, and we've shown that 28 is not a sum of 3 perfect squares, where 1 squared is one of those perfect squares. So we have to keep checking. Maybe we could try 2 squared. Now we can't really add 1 squared because we've already tried that. So let's do 2 squared plus 2 squared. We haven't tried that yet. That's 4 plus 4, which is 8, but that leaves a remainder of 20, which is not a perfect square. We could try 2 squared plus 3 squared, which is 9 plus 4, which is 13. That leaves us a remainder of 15, but that's also not a perfect square. We could try 2 squared plus 4 squared. That's 4 plus 16, which is 20. That leaves us a remainder of 8, which is not a perfect square. And if we try 2 squared plus 5 squared, that's 4 plus 25, which is 29, which is too big. Okay, so now we've shown that 28 cannot be the sum of 3 perfect squares if either of those perfect squares are either 1 squared or 2 squared. So maybe we can try 3 squared plus 3 squared. That's 9 plus 9, which is 18. That leaves a remainder of 10, which is not a perfect square. We could try 3 squared plus 4 squared. That's 9 plus 16, which is 25. That leaves a remainder of 3, which is not a perfect square. And if we try 3 squared plus 5 squared, that's too big since 2 squared plus 5 squared is too big. And we don't have to check that 3 squared plus 5 squared could work since 2 squared plus 5 squared was already too big. Well, maybe we could try 4 squared plus 4 squared, but that's 16 plus 16, which is 32. That's too big. So we've gone through and exhausted every single possibility of how 28 can be written as either a sum of 1 squares, or a sum of 2 squares, or a sum of 3 squares. In every single instance, it's impossible to write 28 as a sum of 3 or fewer perfect squares. And this is the proof. Thanks, everyone, and I'll see you in the next video.